Hi, welcome again to a new Intarcon Academy training session. I'm glad to see that many of you have attended before in another sessions. So today we will very close. We will have an atmosphere so close. And today we will explore the synergy between the Waterloop system and the use of natural refrigerant. So let's comfortable and get started, okay? At first, imagine you are standing in front of a new supermarket about to open in an urban area with high growth prospect, which aim to be at the cutting edge of design and efficiency in this supermarket, okay? And as part of the expansion plan, they need a refrigeration solution for the installation. We are going to meet three main players in this scenario. That will be the property owner, the engineer, and the installer. The objective is clear: offer a quality service in this supermarket. But the question is how this could be achieved without increasing costs while maintaining efficiency and durability. Let's get to know our main character. Will be Anne, the owner of the supermarket, with an eye on profitability and sustainability. She wants an efficient system that reduces the energy consumption and reinforce the green image of this company. And she wonders if is there an economically viable solution that is also respectful of the planet. Next, let's to know Charles, who will be the responsible for design a solution that balance efficiency and regulatory compliance. He must guarantee a reliable, acceptable, and safe system. Okay, he asks himself which refrigeration system will best adapt to the customer's needs while guaranteeing regulatory compliance. Finally, Joe, the one who puts theory into practice, he needs an easy-to-install system with accessible maintenance and guaranteed technical support. And his main question is how simple is the commissioning and maintenance of each equipment, and what resources or training are required for the unit. We can see that there are three different perspectives, but the same objective, that is to find the best refrigeration solution. Here we can see that each of these players has different concerns, but they are closely related. In the end of the success of this project, there will be four key pillars. The first one will be sustainability. Profitability, where we must guarantee a secure and sustainable return of the investment for the property. Next, sustainability, committing to a solution that is aligned with the environmental standards and has a lower environmental impact. Next, regulation, third position, comply with current regulation and anticipate to the future requirements. And lastly, an ease of installation. Ensure that the system is viable in terms of assembly and maintenance and has a long, useful life. These are the main drivers for the project that will guide this project. So now that we have identified the drivers, we must ask ourselves what solution is at the center of all of them. So welcome to the area of natural refrigeration, Welcome to Waterloop R290 system from Intarcon. With this technology, we are taking another step forward to a sustainability, efficient refrigeration, and a better future. How do we can achieve this? Through three main types of units that will be water condenser units, motor evaporators, compact condenser equipment, all with the use of dry cooler to dissipate the heat from the water loop. Waterloop solution provides 8 key benefits for all of the stakeholders. The first one will be ecology, reducing the R290 refrigerant charge. We minimize the risk of leak and reduce the environmental impact. Next one, safety. The decentralization of refrigeration production guarantees high availability of cold along the system. Ease of installation, simple installation with pre-charged units and a low pressure water loop installation. Accuracy, we use optimum adjustment of temperatures, power for each application of each cool room or each workroom. Next, energy safe, use of high efficiency compressor and the use of variable flow electronic pumps and a speed controller fan in the part of the dry cooler. It provides us better energy saving. Next, versatility. In this case, it's suitable for both new installation and for the retrofit of existing installations. In addition, flexibility also keeps change to the layout of units without a major structural modification. And lastly, tropicalization, designed to work in extreme conditions of up to 45 degrees of ambient temperature. Let's see the guide, the contents that we will see today. First, market and regulatory drivers, new developments of R290. Let's see water condenser units, low profile evaporators, motor evaporators, dry coolers, and water condenser and compact units. Different installation application that we are going to see also. Next, different references with success stories. And finally, we are going to give you a solution for the supermarket with the use of Client 360, that is the software that we are using from Intarcon for managed refrigeration projects. The main market and regulatory drivers are three. The first one, reduction in the use of refrigerant with high GWP, because of current and future regulation are progressively limiting the use of gases with high global impact. So mainly we are forced to solution with natural refrigerants such as propane. Next, F-gas 2024 regulation and specific regulations such as EN 378 with a charge limit. These restrictions are being timed with reduction in HVC marketing quota. So the new requirements are very tight with the refrigerant charge in installation. So this guide also to solution with low charge refrigeration systems and the use of natural refrigerant too. Finally, a key point, an important key point, that is commitment to sustainability. Beyond regulations, the sector is responding to the needs and demands of the customer and consumers of the market. So companies are jumping into the efficiency, the energetic efficiency bandwagon, aligning their values with the long-term sustainability of the planet. The challenge for 2025, from 2025 in Europe, a ban of the marketing of compact units that use refrigerants with a GWP higher than 150 came into force from January 2025. The same is true for split units from 2030. So what does this mean for the sector, the refrigeration sector? Traditional refrigerant with high GWP will no longer be viable, forcing the industry to look for other sustainability solutions. At Intarcon, we are anticipating this change by committing solution with the use of a solution with a low refrigerant charge and the use of natural refrigerants. In particular, in this case, R290. So let's see new developments in R290 in the Waterloop system. We have taken further step in the development of R290 solution, evolving toward a more compact and optimized group in the part of the water condenser groups, which provide us a greater operational efficiency, an easy installation and adaptation to small spaces with his compact design, and also improve maintenance and durability. We are focused on the part of the installer. This redesign is not only respond to the market needs, in fact, also respond and anticipate to the challenge that future will give us. This equipment, we are going to look details of this one. This is a water condenser unit designed for medium and low temperature application. They are very compact and silent units that can be installed on the wall or directly on the refrigeration service. So you could adapt itself to different situations. Their key features include compact design, as I said, metal reciprocating compressor or scroll compressor, depends on the model, a condenser with stainless steel braced plate, refrigeration circuit with filter, pressure switches, safety valve. Also, we have a chassis of galvanized steel with sound absorb isolation to minimize the noise emission. Also, in the part of the control panel, we use a circuit breaker to ensure the electrical safety. A new specification that we can find in this equipment will be a removable front panel for access to the unit's main components, such as compressor, liquid receiver, valve, or starter kit of the compressor. Next, the access to independent control panel with front access, in this case, where you can find all the electronic protection and control elements that are integrated in this control panel. Next, the connection that you could find in this slide, in this image, in the right part. We have a solder connection for liquid and suction line. Also, it's optional, a hot gas defrost, so we could find also thread connections for the part of hydraulic circuits, and the safety line that is also important to conduct, okay? Next, which optional we will have in this new development of R290, a hot gas defrost for a more efficient defrost than electrical defrost. The option of the use of water condenser in the range of -10 degrees up to 5 degrees for the use of condensation with chiller. We will have a Waterloop that we will add between -8 degrees up to -2 degrees with the use of a chiller. Next, we will see an example of this installation. As an option also, we can provide you water solenoid valve for installation outside the unit with effective defrost for system that go further one-to-one system. Liquid solenoid valve that could be integrated in the unit in the case that the service will be so close to the unit. Thermostatic expansion valve integrated in the unit to reduce the amount of refrigerant. In the part of electrical switch case, in this case, let's see voltage control in single phase for monophasic model, single phase model, or voltage and phase failure control in three-phase model. Also, the option of crankcase resistance for ensure optimum oil temperature. Electronic control, we are going to work with the XM670K electronic control. That is a parametric control that uses multifunction digital remote control, temperature control with recording the maximum and minimum temperature, possibility of interconnection and synchronization of up to 8 units of a LAN network. And on the other hand, let's see accessories for this equipment, the DM, ND, or SD, depends on the compressor that you use, reciprocating compressor or scroll compressor, supplied separately for better installation, as we said before, water solenoid valve, balance and control valve, in addition, door micro switch or LED room light. It's possible to include. Let's see the installation of this equipment. That could be mural wall installation, and one of the key advantages of these units is the flexibility of assembly in this case, because of you can install in two ways, anchored on the wall, allowing for simple distribution of facility and access for maintenance, or on the top of the refrigeration service, optimizing space and reducing the distance between connections. Let's see now the portfolio products on medium temperature. Let's see, for this equipment we will have a compressor, a reciprocating compressor or a scroll compressor. It depends on the chassis. Chassis 0 we will have reciprocating compressor, and chassis 1 we will have a scroll compressor. We are going to have a horsepower range between 1.4 up to 2.5 horsepower. If we think about the cooling capacity range for a evaporating temperature of -10 degrees, we will have a cooling capacity range between 400 watts up to 3.7 kilowatts. It's important to know, get an eye on this column, this pillar, that will be the condenser airflow. Sorry, that will be the part. The pressure drop that we will have in the plate. It's also important to know the refrigerant charge is lower than 500 grams of propane. So it's properly to install in most of the type of installation. Next, let's see the part of the low temperature portfolio product. Let's continue with the same idea of using compressor reciprocating in chassis 0 and scroll compressor in chassis 1 with the use of horsepower compressor range between 3.4 up to 6 horsepower, and also we obtain for a common application of evaporation temperature of -30 degrees, a cooling capacity range between 470 watts up to 3 kilowatts. Also, we comply the part of refrigerant charge that is lower than 500. Dimension, let's see this equipment for Series 0 and Series 1. Next, we can adapt the water condenser group with refrigeration services, or even we can also use a low profile evaporator that is designed for maximum performance. Focus on the use of spaces that are very reduced. We use axial motor fans that guarantee a great distribution of cold, a high efficiency cooling coil with copper tubes and aluminum fins with 6 mm of fin pitch. We also integrate a siphon in the part of the suction line, and also we include in the lower part an aluminum condensate tray for an easy cleaning and maintenance. As an optional, we could include drain resistant for low temperature models. It's an optional in medium temperature. It's as a standard in low temperature model. Also, we could include a hot gas defrost for an effective defrost better than electrical defrost, or the use of easy electronic fans. We reduce energy consumption, we optimize performance, and we adequate the airflow to each situation of condensing. We can also include anti-corrosion coating on the coil for aggressive environments. Let's see now a render of this equipment. We can see a high efficiency evaporating coil. The part of the electrical connection, interconnection that we will have with a control panel, for example. The use of electronic axial motor fans, and the condensate tray that we mentioned before. For installation recommendation, mailing for each low profile evaporator, it's not only for propane evaporator, it's also a higher recommendation for every evaporator or air cooler that you could install in a cool room. Ensure the direction of the airflow. It's recommended that the air be blown lengthwise in the room, close of the door, to avoid mainly the air condensing of the entry air, okay, and avoiding also blockage due to the freezing air. This unit should be also placed at the end of the cool room, and in addition, the inclination of the drainage could be higher than 20%. Okay. So let's see the main medium low temperature portfolio product. For low medium temperature, we could see, for example, for a cool room temperature of 0 degrees, we will have a cooling capacity range from 500 up to 2.6 kilowatts, or even in a low temperature application, we will have from 370 watts up to 2 kilowatts. Okay, let's see the main coil, the surface of the coil, and the volume that you will have inside the coil. Let's see also the main feature of the fans, the airflow of the fans, the number of them. It depends on the chassis that we will select, the power, the absorbed current, the distance of the airflow. Let's see the different dimensions and the number of fans that you will have in each equipment. So now let's get to know the R290 evaporator with built-in compressor. These are the main features and characteristics that will be the R290 refrigerant charge reduced, ensuring that environmental impact and align with these values. Next, a cubic structure for this evaporator, so we can increase the cooling capacity in the part of the evaporator. The use of hermetic reciprocating compressor or scroll compressor, it depends on the model. And also it's thermally insulated. This is the part of the compressor to avoid thermal transfer. And using also crankcase resistance to optimize the performance of the oil temperature. We also have how the gas defrost in this case. Axial fans. We only have straight hydraulic connection, facilitating the integration with the Waterloop system. And we could include a multifunction control panel or even the water solenoid valve that could be provided a part of the unit to ensure a properly use of this equipment. Let's see a render in the microtube evaporation coil. Let's see the hot gas defrost line, the Waterloop condensing circuit, the inlet and outlets in this part, the plate heat exchanger, the hermetic compressor that is insulated or that is insulated from other compartment. In this case, is a scroll hermetic compressor. As a consequence of this compact equipment, we have a reduced R290 refrigerant charge. For example, the use of axial motor fans that are in the part of the evaporator. So the electronic controller will have these three main functions, such as jet cool fast cooling function, energy saving function, or optional to manage of the air cooled condenser. For the part of loop temperature control and antifreeze protection. In the part of interconnection that we see before, let's see different connection that will have depends on the function of maneuver, proofs, pumps, fans, pumping permits also for this equipment. Let's see an example of installation. Let's see this motor evaporator that cool inside the cool room, the dry cooler that dissipates the heat that is generated in the part of the motor evaporator. In this case, the control panel that regulates the unit. Let's see the main medium temperature portfolio product. Let's see how we use semi-hermetic reciprocating compressor and scroll compressor with horsepower range from 3.4 up to 3.5, and a cooling capacity range for medium temperature from 1.4 kilowatts up to 5 kilowatts. We have increased the cooling capacity range than the use of low profile evaporator. It's a cubic evaporator and we can increase the heat transfer. Let's see also it's important the pressure drop in the part of the plate. Let's see how the refrigerant charge is very reduced. In this column we see also the condenser water flow, in liters per hour for exchange the condensing power that we have created. It's important to dissipate and calculate next the pump. Next, the low temperature portfolio product, the part of compressor. We only have a single model with a reciprocating hermetic compressor. The other will be with a scroll. We obtain a cooling capacity range for cooled room temperature of minus 20 degrees of 800 up to 2 kilowatts. Let's see the water flow condenser that we need to transfer that and dissipate the condensation need, and the use of low refrigerant charge on all of this equipment. See different dimensions and the number of equipments and how it's distributed the part of the evaporator and the part of the condenser, and also the electrical board dimension that you will have for controlling this equipment. Let's see Intertop and Interblock Pro Waterloop. In this case, we see this option in other webinars. In the case we select an Interblock Pro or Intertop Pro, we will have the option of condensing with water at a temperature of between 5 and 50 degrees. This is the main concept of Waterloop system, so we can add or include this equipment in the installation. Same for the Intertop Pro. And the portfolio product, in this case, we will have a compressor from 1.3 up to 1 horsepower. For a cool room temperature, in this case, for the part of Intertop compact units. In this case, if we change the condensing by air, we change for a condensing by water, we obtain a better cooling capacity requirements because of the water transfer is better than in air transfer. So our equipment will achieve a better cool room, will achieve a better cooling capacity for the same temperature in the cool room. So our product range, in our cooling capacity range, will be from 600 up to 4 kilowatts. It's important to know the water flow in the part of the condenser, and we ensure the refrigerant charge is lower than 150. The same for the part in low temperature models. We obtain a higher cooling capacity range from 500 watts up to 2 kilowatts. It depends on the number of circuits we set in other webinar for the Interblock Pro new developments. Also, ensure the refrigerant charge is lower than 150. Finally, let's see the last key component in the system, that is the dry cooler, that integrate the hydraulic group. Okay, with main features that are very low noise level, thanks to the double acoustic isolation, that properly designed for noise-sensitive environments such as hotels. It also has a tropicalized design for an ambient temperature of up to 45 degrees. And it has an optimized heat exchange coil for dissipate the heat. In this case, we can see a render of this equipment, see the heat exchanger. They use a variable frequency driver in the water pump, so we have a variable water flow in the part of the Waterloop condenser. The use of expansion vessel that is properly designed for the amount of hydraulic water that we have inside the Waterloop system. But of this equipment, if in the case the installation will be higher, we'll have a higher dimension of the quantity of water that you have in the installation, you will have to add a new expansion vessel in your installation to adapt of the difference of thermal densities that you can have in the part of the low temperature or in the part of high temperature. Let's see if we have all of them with a variable flow control. The number of fans will increase in depends on the chassis, the model, and the water flow that is previously dimensioned and select the power, the pump before the installation. We ensure also a pressure drop, available pressure drop of 100 kilopascal, and we can see also how the sound pressure level is very low for this equipment. Let's see the dimension, the number of fans that you will have in each series. So let's go to the application. That is the finally, I think, the most important part, the part of application, how we can go from the theoretical part to the practical part. In this case, we can see a Waterloop system. As we said before, it's very versatile solution. It's a very versatile solution. And we can see the main different points in this supermarket case. For example, we will see condensing units at high temperature, water condenser units at high temperature, positive and negative temperature too. The use of the Waterloop that is along the supermarket. The use of air conditioner for heat recovery of the water loop. In this case, we use this heat recovery to reduce the energy consumption in the supermarket. And even finally the dry cooler in the part in the outside part that we will use for dissipate the heat from the Waterloop unit. Next, we can also see different industrial uses, such as industrial kitchen, for example, or along the HoReCa sector. It's important also to know because of it's an efficient safety solution for professional and food application. Let's see this Waterloop that we'll have along the kitchen. Let's see the double flow evaporator in this case that we will have, for example, for a workroom needs. The use of condensing unit at positive and negative temperature we use for services, refrigeration services, or even for the evaporator. And also the use of a cubic motor evaporator at negative or positive temperature. Okay, and also finally we will have the dry cooler outside that dissipate the heat we will have in the part of the condensing sector. Now let's see an example of distributed installation of Waterloop, more an schematic solution. Let's see, the key points will be that we will have a distributed refrigeration along the units. We will have also the part of dry cooler we will have outside. We also have an installation that is an inverter return. In this case, let's see the use for group water condenser units for medium or low temperature in the part of refrigeration services. The use of Intarcon Pro, that is condenser by water. And finally, in the final part of the installation, we will have a liquid liquid valve and a pressure differential valve that ensure the minimum water flow that you will have in the Waterloop system. It's important to ensure. Okay, with also the use of shut-off valve to maintenance this valve. Also, recommendation will be the use of automatic bleeders in the highest point of the installation to eliminate trapped air, or even you could incorporate air traps and drain valves in the lowest point. In this slide, we have a variation of the Waterloop system where we use a water chiller. Chiller in this case would be, for example, with propane that we incorporate for cooling the Waterloop installation. So we can supply different equipment and also different cool rooms needs. For example, for positive temperature, we could have an air cooler to ensure properly the cooling efficiency in this cool room. Here we can see a mixture between a chiller system and a Waterloop system. So let's see different success stories, such as supermarkets. In this case, we could have water condenser groups. For example, in Santon Market in Madrid, let's see the part of the hydraulic connection, or different kitchen where you can see the use of motor evaporators in the part that is a safety solution for food application. So finally, let's see a solution for supermarkets with Client 360, okay? In this part, I have created before a project in Client 360. You have to log in and you will have access for the premium needs. In this case, I have before calculated several cool rooms on thermal loads, for example, for preservation of fish or fruit and vegetable, or even for a service. Let's review one of them. That is a common display. In this case, we will obtain the result of the thermal needs that you have to insert. In the next webinar, we will see a profound vision of the project part, in the part of the project. Let's see how we can handle and manage different projects simultaneously. But today we are going to do a briefly comments. Okay, so we have to insert this total cooling capacity with the use of our water cooled units. Okay, that you have in the left banner in the part of outdoor units, water cooled units. Let's see the use of propane units. In this case, we can calculate for different conditions. Okay, all of them. And we have to select the better solution for this equipment. It depends, and will be with the hermetic compressor or else with a scroll. So let's select a model that could adapt for this equipment. Okay, this for example will be a properly solution for this need. And we can also save this solution in our project, so we can continue next working after saving them. So we will have the part of the condenser unit, water condenser unit, and the part of the thermal load that we will have in the supermarket. In addition, we could calculate the hydraulic pipes. That is very important, I think, to know. We also calculate, we can know in the part of networks, hydraulic pipes. Let's see, for example, calculation for the use of water. A cooling capacity, a total cooling capacity on the first part, we go step by step, part by part, as you know, in the calculation of hydraulic pipes line. Let's see the fluid delivery temperature will be 40. Okay, and for example, the material will be PPR, and it depends on the cooling capacity that we will have in this part. For example, the cooling capacity. It's provide us a possible solution, a selection for this need that ensure the pressure drop, the condensation that you will have also in the outside part, and the thermal load loss that you will have in this part. Also important, the total amount or refrigerant charge that we will have in this case, it will be water. It depends of the nominal diameter and the pipe length, in this case, for example, for 10 meters. It calculates also the total refrigerant that you will have, in this case of water. So finally, you will have an holistic layout of the installation where you can see very precisely the total amount of refrigerant charge that we will have in each part. You will have two lines, the inlet and outlet. So it will be the total sum of them per 2. Okay. So this is a briefly application for supermarkets. So finally, I will try to respond all of your questions. In any case, if I couldn't respond, I will try to respond later. I aim you to keep in touch with us, to bring us different installations that you will have, and we are going to try to provide you a better solution of them for an hydraulic calculation, or even for a better suitable solution for your refrigeration needs. Okay, so I'm going to see your comments. If there are any doubts in this case.